An inflated airbag requires 60 liters of nitrogen gas at STP in order to protect the occupant of the vehicle. How many moles of nitrogen gas would need to be created in 40 milliseconds to inflate the airbag? Well, we just had the equation where the number of moles, N, is equal to your sample volume divided by the molar volume. So it turns out you don't need this at all. That's just thrown in there for educational purposes, but not needed for the problem. So the volume is 60 liters. VM is 22.4 liters. You can see how liters cancels out, and you do the division, and you get 2.7 moles. So let's check it with the answer here. 2.7 moles. We now have three formulas for finding the number of moles of a substance. It depends on what you're trying to find or what you're given as to which one you use. So let's start here, number of particles, and N is going to be the number of moles in all cases. So big N would be your number of particles of your sample. Na is Avogadro's number, 6.02 times 10 to the 23rd. If you're dealing with masses, you have your sample size mass there, and then you have your molar mass. That's what big M is, molar mass. And if you're dealing with volume, you have the sample size of your volume, and then you have your molar volume, which is 22.4 liters at STP. This is the only guy you have to find from the periodic table, where you look at the atomic mass units. Sometimes two of these formulas must be used together to solve a problem. So here's an example. How many atoms of carbon are present in a 24-gram sample of pure carbon? Here's our equations. Okay. So here's the number one, here's the mass one, and here's the volume one. So if you'd like, see if you can solve that on your own before going to the next slide. Okay, hopefully you got the answer. If not, here's how you would do it. It's a two-step problem. We want to find out how many atoms of carbon are present in a 24-gram sample. So first, find the number of moles of carbon present. So we have N equals the sample mass over the molar mass. So we go to periodic table, we find carbon has 12 AMU as its atomic mass. So that translates into a molar mass of 12 grams per mole. We have 24 grams here, and we find out we have 2 moles. Now, find the number of atoms in 2 moles. That's this equation. Now we're looking to find the number of atoms, that's this guy right here, in the sample. So we rearrange it. We have big N equals little n times Avogadro's number. That's Avogadro's number. So we have 2 moles times 6.02 times 10 to the 23rd atoms per mole, and this gives us 1.2 times 10 to the 24th atoms. Here's another way of visualizing the three equations. If we're dealing with particles, such as atoms, ions, molecules, etc., we use this formula here, where we have Avogadro's number. So all we need to know is the number of particles we have, and then we can find the number of moles. The volume is also very similar to finding the number in that the denominator is already given. It's 22.4 liters per mole, so you don't have to do any work there other than input that number. The only one where you have to do research is when you're dealing with the mass. You have to find the molar mass, which is this big M, by looking at the periodic table, find out its weight in atomic mass units, and just turn that into grams per mole. It's the same number, and that would give you big M, and then you can proceed like you did over here and here. So these two on the right, they give you the denominator. The one on the left, you have to find it from the periodic table.